Assalamualaikum and hello everyone. In this video, we're going to learn about the chemical properties of benzene. So we're going to explain the electrophilic aromatic substitution reaction of benzene, which we have for nitration, halogenation, Friedel-Crafts Alkylation, and Friedel-Crafts Acylation. And we're going to illustrate the mechanism for these four reactions. And we're going to explain the following reaction of alkylbenzene, which is oxidation, and the halogenation. Okay, so let's look here. Okay, so for benzene, okay, here it mentioned similar to an alkene, benzene is susceptible to electrophilic attack because of its exposed pi electron. So sebenarnya benzene kita ni sebenarnya, for example here we have 4 electron here kan. So sebenarnya our benzene ni is actually a nucleophilic site sebab dia rich dengan elektron. So what would happen, usually the reaction ni kita dengan electrophile lah. Sama juga dengan benzene kita where we have carbon sama juga dengan alkene kita, carbon-carbon double bond, kita usually akan reaction dia dengan electrophile kita. But then for this reaction dia tak undergo addition. So contohnya kalau benzene ni kan, dia tak undergo addition sebab if it undergo addition, so it means double bond ni dah tak ada lah. So nanti kita akan ada 2 different product here, double bond akan will be replaced. Okay, but then again, the stability of the pi electron system will be lost if benzene undergoes addition. Sebab actually the reaction in benzene ni is stabilized by the resonance structure. So memang kita perlulah ada alternating single and double bond ni yang conjugated system kita. So that's why it won't undergo addition reaction because we want to maintain this pi electron for the for the resonance lah, resonance stability due to the resonance. Okay, so that's why lah benzene undergoes masih lagi electrophile yang ni, tapi dia adalah electrophilic aromatic substitution reaction. Okay, so next kita akan tengok there's 4 type of electrophilic substitution. Okay, so let's look for the first case. Halogenation, the substitution of halogen. So when we look here, benzene ni kan ada carbon, ada 6 carbon here. When we count, we only have 3 bond. So maknanya satu tu adalah CH bond lah. So kalau misalnya buat expanded, so maknanya we have C6H6. This reaction is actually substitution of electrophile. So this is your electrophile, tapi AlCl3 is your catalyst which increase polarity ataupun produce positive halogen ion. Okay, so that's why lah condition dia kena guna halogen dengan ada kamu punya catalyst ni lah. Tengoklah kalau Cl dengan Cl, Br dengan Br. Okay, so what will happen is we're going to replace H dengan Cl ni, and then we will have Cl bonded to benzene, which is our chlorobenzene. Okay, so what happen? H ni akan gabung dengan another of our Cl atom. Sebab, okay, Cl tu satu dah substitute dalam benzene, another one combine dengan hydrogen. So this is the product. Okay, the same goes here. Also, this is skeletal structure. Okay, setiap satu carbon adanya hydrogen. So sebenarnya benzene ni dia punya molecular formula dia adalah C6H6. Yang ini tak ada apa-apa substituent lah. So Miss pilih contohnya ada satu H kat sini. So what I'm going to form adalah the same one as previous example. It's just that for this one we're going to use Br. Okay, so what is our byproduct? Again hydrogen, because one of hydrogen is being substituted, and we're going to combine it with bromine. So this is example B. Example C. So yang ini lain dia, we have our methyl here. Again we want hydrogen substituted to benzene yang react. Okay, so if we have CH3 here, sebenarnya our hydrogen is bonded to the carbon, bukan pada benzene. So kita tak nak react dengan hydrogen pada carbon CH3 tu lah. We want the hydrogen attached to benzene. So we have another 5 hydrogen. So any of it lah kita boleh pilih, not from CH3. Okay, so if I took from down here, so CH3 ni memang ada. Okay, maknanya kita akan pilih satu di bawah ni. Okay, so hydrogen we're going to substitute with the one downwards. So we're going to form this product. For example D, okay, dengan bromine pula. But make sure hydrogen tu we want the hydrogen attached to benzene. Okay, sebab remember each carbon mesti 4 bond. This 2 dah cukup. Okay, this 4 tidak cukup 4 bond. So maknanya it's bonded to another hydrogen. So choose which one that you want, mana-mana lah. So I'm going to take the upper one. Okay, so here Br plus dengan HBr. So that's for halogenation reaction. Remember, hydrogen tu mestilah attach to your benzene. Tak nak yang H attach pada metal semua tu, pada your alkyl group. Okay, so dalam case ni, our electrophile, because this is actually electrophilic substitution kan, electrophile kita adalah chlorine atau bromine. For the case of nitration, substitution of NO2, so dalam case ni electrophile kita adalah NO2. And NO2 is formed from this condition, which is we're going to combine H2SO4 and HNO3. Okay, what happened? We're going to replace hydrogen ni dengan our NO2. Okay, so any hydrogen lah. So must be hydrogen attached to benzene. So question B pun sama juga. Our electrophile form adalah NO2. Okay, and this carbon we do not have any hydrogens, but dah cukup 4 bond. So maknanya this the rest of the carbon here ada satu hydrogen attached to it. So choose any hydrogen. So contohnya we have our metal pada carbon 1, 2. So mana-mana pun boleh. So what we're going to replace adalah our NO2. So that's it for nitration. Okay, nitration is actually a chemical test. So when we form our nitro compound here, there's an observation which is yellow oil is formed. Okay, so that's for nitration. Now let's look for the Friedel-Crafts Alkylation. We're going to substitute alkyl group. So we're going to use haloalkane and Lewis acid. Remember, kena tengoklah catalyst based on halogen. So first kita tengok daripada example A. So what we have here is actually, again, remember benzene sebenarnya C6H6. So kita akan substitute one of the hydrogen with our electrophile. Okay, so again H ni akan gabungkan dengan Cl. So we're going to form our byproduct. Okay, tapi hint sebenarnya senang nak buat adalah kita asingkan positif dengan negative charge. Okay, sebab nanti positive charge ni adalah electrophile. And remember, ini adalah electrophilic substitution kan. So electrophile kita adalah our carbocation. So carbocation is carbon pada positive charge pada carbon. So what we have here, ini adalah electrophile kita. So this is CH3. Okay, lepas tu H ni akan gabungkan dengan our chlorine. Okay, so for example B. So dalam case ni, again, masih lagi menggunakan dengan haloalkane. But then here we have 2 carbon. So CH3 CH2 plus dengan Br minus. Okay, so when we draw the product, so apa yang akan jadi? Okay, so kalau if it's confusing for you, kita buat expanded. Okay, so again, positive charge is actually pada carbon yang attached pada bromine next to it. So bromine adalah negative charge. So CH2 CH3 ni yang akan bonded to our benzene, bukan CH3 CH2. If you be unsure, kita buat expanded form. So let's do the expanded form. So maknanya dia attached pada carbon ada 2. Remember, each carbon mestilah ada 4 bond. Okay, so mesti adalah. So tambahkan, okay, kita akan cukupkan each carbon tu with 4 bond. Okay, we're gonna tambah dengan hydrogen. So that is for our product. Byproduct kita H2 campur dengan Br. Sebab H ni sebenarnya H plus, tu Br minus. Okay, so that's for B. So ini adalah hint kamu. So hint sebenarnya for this Friedel-Crafts Acylation adalah draw expanded form. Lepas tu we're going to put positive charge is actually pada carbon next to the carbon that attached to our chlorine ataupun bromine. Okay, so let's look here for example C. Okay, so yang ini we can't see it clearly. So I'm going to do my expanded form. So CH3 CHCl dengan CH3. Okay, so next adalah kita kena put the charge lah. Okay, so kita tahu akan replace dengan hydrogen. Hydrogen akan gabung dengan Cl, which is Cl minus. Positive charge mestilah carbon yang attached kepada dia. So here is my C plus. So what happen here adalah HCl ni akan gabung. So I'm going to do my byproduct first. Okay, so what is left adalah our benzene. Okay, lepas tu benzene ni akan attach to our C plus ni. So C plus ni, okay, tapi make sure, okay, carbon ni mislabel lah, senang, carbon A. Okay, carbon A ni dia attach pada 1 hydrogen. Okay, so I'm gonna draw 1 hydrogen here. Lepas tu carbon dia attach pada CH3 kita ni lah, carbon B ni. So yang ni miss buat expanded je semua. So this is my carbon B. Okay, tapi jangan lupa carbon baru ada 3, but actually carbon mesti 4 bond. Maknanya ada lagi satu carbon, ada lagi satu lagi bond which is attached to another CH3. So this is my carbon C. Okay, so this is actually the answer for question C. Okay, so jangan lupa tengok pada hint ni jugalah. Okay, so if you be unsure, jom kita tengok next example D. Okay, carbon ni dia attach pada 3 CH3. So we're gonna do attach to 3 methyl. Ada 3 methyl kita, lepas tu bromine. So here is positive, here is negative. Okay, again mesti tunjuk hydrogen ni. Nak tunjuk, we're gonna substitute this one, hydrogen ni, dengan our electrophile, which is our carbocation lah. Okay, so senang buat byproduct HBr. So what is left is actually our benzene attached to carbon in the middle here, carbon positive charge ni. Okay, so yang ini kita buat to our carbon here, tapi carbon kita ni, remember dia attach, carbon A kita ni attach pada 3 methyl. So dia ada cukupkan 1, 2, 3, 4 bond kita. Lepas tu dia sebenarnya attach pada 3 of our methyl. Okay, so that is actually our product. Okay, so question E dengan F you should try yourself, but here Miss bagi hint mana yang positive charge tu. Okay, so here carbon dengan chlorine ni, so positive charge pada carbon attached to chlorine. Okay, this bond pula, okay, this is bromine, negative charge, so here will be my positive charge. Okay, so if you be unsure pasal positive negative charge ni, nanti kita akan nampak lebih jelas bila when we draw the mechanism. Okay, now let's look for the case of Friedel-Crafts Acylation, substitution of acyl group. So what's the difference kalau alkyl group ni, and ni kita punya alkyl lah. Acyl group ni adalah, beza dia ada C double bond O attached to our alkyl group. So this is what we call acyl group kita. Okay, so our electrophile is actually our C double bond O attached to any alkyl group lah. Okay, yang ni mesti buat lagi satu so that we show that carbon have 4 bond. Okay, so nanti hint kita is that we're going to put positive charge on carbon yang attached to double bond O. So let's look for example A. So here COCl. So C double bond O. Okay, carbon mesti attached to 4 bond. So we have here CH3 dengan Cl. So I'm going to write down CH3Cl. Okay, so how about the charge? Positive on carbon double bond O, negative pada chlorine. So here since it's electrophilic substitution, okay, hydrogen akan gabungkan chlorine to form HCl. Okay, we're gonna attach our electrophile, okay, to our benzene. So it must be C double bond O. So here I'm going to write down C attached to double bond O, and then our C lagi bonded to CH3. So that is our substitution of acyl group. R2 any alkyl group kita lah, dalam kes ni CH3. Okay, now let's look for example C. Okay, so example C here. So kita tengok pada kita punya acyl chloride. So positive charge again pada C double bond O. So hydrogen akan attach with chlorine. Hydrogen will react with chlorine. Okay, so what will happen adalah C double bond O. So here is our carbon yang ada attached pada double bond O, and then carbon double bond O is attached to cyclohexene. Okay, so this is actually the product for question C. Okay, for the acyl group ni, again dia adalah C double bond O, and attached to it ada kita punya alkyl group, so salin sahaja. So again for Friedel-Crafts Acylation dengan acylation, remember positive charge to the carbon, and that will be our electrophile. So question B and D you should try it yourself. Okay, now let's look on page 7, the reaction of benzene involve the substituent. So actually yang ini reaction for alkylbenzene lah, any alkyl attached to our benzene. Okay, so first kita akan tengok is oxidation. So this is actually the condition, mostly is going to KMnO₄, K₂Cr₂O₇ pun can be used. So here what we have here is our CH3. So tapi senangnya oxidation ni, senang produk dia is only benzoic acid. So kita tengok dekat sini, we have our CH3. So what would happen? Our CH3 will become COOH ataupun our benzoic acid. Okay, tapi macam mana pula if we have here 2 carbon? So kalau 2 carbon pun sama juga, when we go undergo oxidation, it will become benzoic acid regardless of how many carbon attached to how many carbon attached to benzene, it will become carboxylic acid. Okay, so question C, but then here we have 2 different carbon kan, so maknanya kita akan form 2 carboxylic acid here. Okay, so again the hint must be any alkyl group attached to benzene lah. Kalau it's not alkyl group, tidak akan form carboxylic acid. Question D, so what happened here? Here akan jadi COOH, tapi NO2 is not alkyl group, so there's no change. So that's for oxidation. Now it's for the halogenation. So halogenation ni substitution of halogen. Ini adalah revision from your alkane. Okay, so which is your free radical substitution. So now let's look. Okay, so just for the revision. Okay, remember for the halogenation, check the class of carbon and ataupun samalah hydrogen to itself. Okay, sebab if we have different class, so we're going to have different product. So we're going to have major and minor product. Okay, remember tertiary is more stable than secondary and more stable than primary. Okay, remember this reaction is actually for alkylbenzene. It means that alkyl yang attached pada benzene. Hydrogen tu tidak ada any reaction lah. Okay, so let's look here. Carbon kita ni attached to one carbon. So the primary hanya ada satu sahaja. So there's only one product. So we're gonna have Br substituted. Okay, question B. But when we look here, okay, again benzene tak ada reaction. Any alkyl attached to benzene sahaja. Okay, so this carbon, the first carbon here, we have 2 carbon attached to it. Okay, satu pada carbon yang sebelah dia, satu pada carbon benzene. So here is secondary, this one is primary. So when we have 2 different class, we have major dengan minor. Okay, again major dengan minor tu is actually mono substituted. So only one sahaja we're gonna substitute our hydrogen. So first I'm gonna show the major product first. Okay, and then I'm going to label it as major. Okay, and then don't forget, because we have 2 different product, major dengan minor, so we have to write down both lah, plus dengan minor product. So minor product pula is actually if we substitute Cl to the primary carbon ataupun primary hydrogen itself. So I'm going to label it minor product. Okay, question C and D, you should try it yourself.